Right now we're going to factor the difference of squares. The difference of squares is when you have two perfect squares being subtracted. And if you think about it, go back to your special products, this is what we got when we multiplied the product of a sum and a difference. Right here we've got the product of a sum and a difference. And remember, when we multiplied these out, it always worked out that our two middle terms canceled out, and we were left with just a squared minus b squared. So what we're going to do today is we're going to use this idea, this logic behind these special products, to go from this answer back up to our factored form. And the way we do that is we're going to break apart each of these perfect squares. We need to find the square root. So the square root of a squared is a times a. The square root of negative b squared, if I do this, I'm going to get b times negative b. And then what I do is I take each of these terms, I'm going to take 1a and put it in each parentheses, just like this. I take 1a here and 1a there. And then what I'm going to do is I'm going to take my b's and break them apart too. I'll put 1b here, this is my plus b, and then I'll take this b here, my minus b, and put it on this side. And we can see that what I've done when I've broken it apart is I've ended up with the product of a sum and a difference. So let's try this with numbers now. Again, what we want to do first is look for the square roots of each term. So this is x times x. Negative 64 is going to be 8 times negative 8. And then to write this out, I'm going to do x, 1x from here, and one of my 8's from here. I'll put my positive 8 here. Then I'm going to take this other x, and I'm going to take my other 8, which is my negative 8, and put them in my parentheses. So again, what I've done is I've broken up these x's, like that, and I've broken up my 8's, put one in each parentheses. And that leaves me with the product of a sum and a difference. Now it's really important to know that this only works when you have a difference of squares. Okay, this is an addition problem. So since this is addition, it's not a difference of squares. And let me show you why it won't work. If I were to break this a apart into its square roots, I'm going to get a times a. If I break this 49 apart, since it's positive, I get 7 times 7. Following that same pattern, if I were to split this up, I would get a plus 7 times a plus 7. This is not the product of a sum and a difference. This is the square of a sum. And if I were to multiply this out, it's going to follow this pattern, a squared plus 2ab plus b squared. Okay, if I multiply this out, I'm going to end up with a squared plus 14a plus 49. And that is not what I started with. So remember, this idea only works when you have the difference of perfect squares. It has to be subtraction, not addition. The last thing you want to remember is that whenever you do any kind of factoring, you always want to look and see if you have a GCF. Okay? If I look at this problem, I see that my GCF is going to be 3b. Okay, so the first thing I want to do is take that 3b and pull it out of my problem. And when I do that, I'm left with b squared minus 25. Well, when I look at b squared minus 25, I see this is a difference of squares. B squared is a perfect square, b times b. 25 is a perfect square, 5 times negative 5. So what I can do is I can factor this again. I have my GCF out front because that's one of my factors. And then I'm going to have my b, and I'll have plus 5. And then in my second parentheses, I'm going to have a b and my minus 5. And that's my difference of squares. So that would be the factored form of this problem right there.